Number 26. The functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? We have function 1, f of x equals 18 times 1.25 to the power of x plus 41. And function 2, g of x equals 9 times 0.73 to the power of x. So these are exponentials, a number to the power of x. Immediately, we want to be thinking Desmos. Don't try graphing this by hand. Is it possible? Of course, anything's possible. Don't do it. But what does this question mean? What are they asking us? As a constant or coefficient? Get used to this because boy, do they love questions that ask this. Which of these questions displays blah, blah, blah as a constant or coefficient all the time? A constant is a number that doesn't change. 5 is a constant. Negative 22 is a constant. 1,000 is a constant. 1/4 is a constant. A constant is not a variable. It's a flat number. It doesn't change. A coefficient is a number that is multiplying by something, like 6x. 6 is my coefficient. X is being multiplied by it. So when we look at these equations and look for constants or coefficients, you're just looking at the numbers, the plain numbers. So what are my plain numbers in f of x? My plain numbers are 18, 1.25, and 41. Those are my constants or coefficients. In my second one, g of x, my plain numbers are 9 and 0.73. Those are my constants or my coefficients. Now, okay, so it's saying which of these displays the maximum value of the function it defines. Now, when we talk about maximum values, a lot of times we're thinking of things like parabolas. We have, an upside down, a downward facing parabola. We have a maximum value there. That is the vertex. It's the highest that it goes. Some functions do not have maximums. A line does not have a maximum. It goes up and up forever. A cubic does not have a maximum. It goes up and up forever. Exponentials do not have maximums. Exponentials can come in 4 different varieties. They can look like this, like this, like this, or like this. Those 4 main, that's your varieties of exponentials. So like in this case right here, they're going down, to the left, and they're going up forever to the right. This one, they're going up forever to the left. Here, it's not going up, up, up forever. It's approaching a limit, but it never crosses that limit. So there isn't a strict maximum point. It gets close and close. It'll say the limit, and same with this one. It goes up and up and up, and there's a limit. It never touches that limit. It gets closer and closer and closer, but there isn't a true maximum point. And likewise, there's no true minimum point. So how could they ask this? How could they ask what's the maximum or minimum of this function? It's right here, where x is greater than or equal to 0. That's the only part of this we're going to look at. So let's go over to Desmos and look at these two. And here we go. We have f of x here in red and the g of x that's going up to the right, and we have g of x in blue that's going down to the right. They're both approaching their limits, and they're also going up into infinity, just in different directions. So this one's approaching a limit, looks like it's 41. It's approaching 41, and it's going up into infinity. This one here goes up into infinity negatively to the left, and it's approaching 0 to the right. Yes, I know it says 0 over there. It's not actually touching 0. It just gets so small that Desmos isn't registering it, but it doesn't actually touch 0. Limit fact. All right, so when x is greater than or equal to 0, let's just move it over. So we're only looking at that bit. What are the maximum values of this thing? What's the maximum value of this where x is greater than or equal to 0? There isn't one, because it's going up and up forever, right? When x is greater than 0, there is no maximum. It just goes up forever. Now, our g of x, our blue one, when x is greater than or equal to 0, there is a maximum point. This is the highest that it gets. It's 0, 9, and then from there it goes down, and it goes smaller and smaller towards that limit of 0. But yeah, it has a maximum point. When x is greater than or equal to 0, the maximum point is 9. And Is 9 anywhere in here as a plain number, as a constant or coefficient? Yes, it is. Right there. So f of x does not have a maximum, so there's no number to compare to see if the maximum matches any of its constants or coefficients, because the maximum doesn't exist. And then here, the maximum does exist. It's 9, and sure enough, there is a 9 right there. So g of x is the only one. So let's go back to our thing here. Okay, so what are our options? We've said that it is not the case in number 1, but it is the case in number 2. Our options are 1 only, that's not true. 2 only, that looks like our right answer. 1 and 2, nope. Neither 1 nor 2, nope. There we go. B is my answer.